Hello, I'm audible.
Yes, sir. Good evening, sir.
Good evening. So today we are going to discuss interim PYQs, and if you have any doubts in any activity questions or any graded question, you can also ask.
Okay, sir. So, can we ask any other terms of PYQs?
Yes.
Yeah.
So in last session we discussed this. Hello. So in last session we discussed this question paper, right? Up to this question. So let's start from here. So we have a question. So this is a question. So the question is saying for a domain D is a subset of R2 and this function is defined from D to R. Be a scalar value function and defined by the formula. So this is our function f of x comma y, and this function is defined like this. And the question is asking which of the following is the largest possible set that would be valid domain D for the given function. The question is asking which will be the valid domain for this given function. So which one will be? So it's 0 comma 0. So it's 0 comma 0 is if you put this is defined. If you put 0 comma 0 into this
No,
function,
no,
what we get?
no, infinity, not different.
Yes, my screen is not visible.
Visible.
Visible, sir.
Okay, so means this function is defined on all R2 except 0 comma 0, right?
Yes, yes.
Means so which option is satisfying? So the first option saying is this domain is R2, so
Sir,
R2
which
contains 0
paper
comma 0.
is? Sir, which paper is this, sir? Which
So
solving?
I think this one. So this paper is September 24th.
Okay.
So means this function is only defined. This function is defined all R2 minus 0 comma 0, right? So the domain of this function will be all R2 minus 0 comma 0. Means which option is satisfying? The second one, right? Means the this value will not equal to 0. Means if so, what will be 1 by 0? This is not defined, right? 1 by 0 is infinity, so this is not defined. So this option will be correct. Anyone has any doubts in this question?
Sir, can you explain it how?
So this is our function.
Okay, you are putting the value of this 0, 0, and okay, sir.
Yes, means if we put 0 comma 0 here, if the value of x square plus y square is equal to 0,
It will be 0, and
can this
it will be undefined.
function will be undefined, right?
Yes.
So this function is defined for all R2 except this value, right? 0 comma 0. Means this will x plus y, x square plus y square cannot be 0. So this will be not equal to 0, right?
Yes, sir.
So the second option is here, satisfying
We
this
are confusing.
condition. So in this question for D, so D is defined like this: a set of all x comma y belongs to R2 such that x square plus y square is less than 1 by 2. So this is what? This is some equation of circle, right? This one, x square plus y square is less than 1 by 2. So what will the value of x and y this domain will take? So this is circle, right? This is equation of circle, and radius is what?
Less than half.
Hello,
Less than 1 by root 2.
So radius is 1 by 2, right?
1 by root 2.
hello. Yes, radius is 1 by root 2. Means, so if the domain is defined like this, so what will be the range of this function? So then what will be the range of this function? So here domain is this, means this will this domain contain all the x comma y that lie inside the circle. This is circle, right? X square plus y square is less than 1 by 2. Means all the point inside the circle, not lie on the circumference of the circle, right? This one.
Mm.
So what will be the maximum value of this function if you take this as a domain? So so this is our function, and domain of this function is defined like this here. The question is asking for what is the range of this function. So what is the minimum value of this function? So this is some equation of circle. So this one is this circle, and this function will take all the value inside of this circle, not this boundary. This function will not take this point on the boundary. This only take inside this. So what will be the minimum value of this function?
Just greater than 2.
So minimum value will be what? This will be 2, right? If you take 0 comma 0,
Yes, 2.
just
And
0
you,
we just, so first look at the what is the minimum value. So if you take minimum value, this will be what?
1 by 2, no?
Yes. So this will be, for finding the minimum value of this function, so this value will be maximum, right? This one will be maximum, this quantity. Suppose I want to find the
Yes.
minimum. So the minimum, so maximum value will be what of this domain? 1 by 2, right?
Okay,
Yes.
yes. Because
So
it is less than
basically,
1, right, sir?
hello.
Yes, sir. X square plus y square is less than 1 by 2. That's
Yes.
why, sir,
So
minimum value of x square is 1 plus y square is 1 by 2.
yes. So for finding the minimum value of this function, we have
Yes.
to find what
Maximum
is the
value of x
maximum
square
value.
plus y square.
Yes. So
Yes,
maximum value of the domain is what? This 1 by 2, right?
1 by 2.
So if you take x square plus y square is 1 by 2, what we get?
It goes up. Yes, sir. 1 by 2 is 2.
But this will not include, right? But
Yes, sir. Not included. 2 is not included.
the minimum value of f will be 2. And what will be the maximum value of this function? So
It goes up to
finding
infinity.
the for finding the maximum value, we have to minimize this one, right?
Yes, sir.
So what will be the minimum value? This will be take x square plus y square.
0.
So this can be 0, right?
0, yes, sir.
So 1 by
Not,
0, what
not
you get?
zero will not there. Nearby zero, I think.
First is just check 0 comma 0 square plus 0 square is less than 1 by 2.
1 by 2.
Yes, sir. It is.
So maximum value of this function will be what? Infinity, right? And this both are not included, means so the range of this function will be 2 to infinity. What this? Anyone has any doubt? Hello.
How
Yes.
did you write the one by x square plus y square?
So this is our function. This is
Okay,
We are,
okay.
we are finding the range of this function. And the domain of this function is defined here using.
Okay, okay.
Uh,
Hello?
the minimum value is calculated
Hello?
to 2. But
Not
what's the
exactly,
like?
not exactly, not exactly 2, but it will be 2. This will be less than or equal to 2. Less than. Hello?
So in range itself, 2 is not included.
Yes. So
Yes.
we take this right here. This
Yes.
2 is
We
not included. Open, we take open bracket. 2 is not included, but at this minimum value will be less than or equal less than 2, right? This will
yes.
not include.
Sir, if it
Hmm?
was given a half, it
Hmm?
was given like half, then like
Hmm?
when half is like given, then 1 upon 1 by half you have calculated.
Yes, yes.
Why?
So this is our function, right? So for finding the minimum value means we are finding range, right? Range. So this is our. So what will be the minimum value of this function? So this is our domain. This x square plus y square is less than 1 by 2 is our domain. And this is a equation of circle with radius 1 by root 2. And the domain take all the point inside this circle. Inside the circle, but not on this boundary of the circle. So what will the for minimizing this function, we have to maximize this, right? We have to maximize this term x square plus y square. So the maximum value of this will be x square plus y square will be what? Less than 1 by 2, right? This radius is 1 by 2, 1 by root 2. The maximum value will be what? Of this 1 by 2. If we put 1 by 2 here, we get 2. Hello?
Yes, sir. It says kx square y square is the equation. It is was less than half.
Yes. The doubt is clear? Hello? Can I move to the next question?
Yes, sir. You can move forward.
So, question is saying for which of the following choice of D is the function is injective? So, what do you mean by injective function? Hello? Hello, Anurag?
Can you repeat the last one?
Hello?
Hello. Am I audible?
Yes?
Can you repeat the last one?
Okay. This question. So, here, basically, we want to find the range of this function. So, for finding the range of function, we have to first find the minimum and then what what is the value this function will take maximum. So, what is the maximum value and the minimum value of this function? So, if you find the minimum and maximum value of this function, we can bound the range of this function. So, the minimum value this function will attain when this x square plus y square is less than 1. So, we just check this value x square plus y square is less than 1 by 2. Just to, so we want to minimize this function. What is the minimum value of this function? So for finding the minimum value, we just take which value, what will be the maximum value of this x square plus y square. So the maximum value will be this what? This 1 by 2. We just put 1 by 2 here and we get this 2. So this is the minimum value we get. And for finding the maximum value, we have to minimize this quantity x square plus y square. So the minimum value this function will take 0 comma 0. If you put 0 and 0, we get 1 by 0. This will be infinity. So the maximum value of this function will be infinity. Got this? So this is the next question. For which of the following option of D? Okay, let's answer this one is simple question. So x minus 1. So tell me what will be the minimum value of this function? Hello? If the domain
Could you
is,
please?
Minus infinity.
so I just take domain here. Domain is from 0, or domain is from 2 to 2. What will be this? So minimum value of this function will be what?
1.
2 minus 1, 1, sir.
1, 1.
1.
And the maximum value will be?
One again.
So
1, 1.
okay, I think this is not the function. Okay, okay, I will just grab this function and it will be easier to understand. Just wait a minute. So my screen is visible. Hello.
Yes, sir.
So this is our function, and we want to find the minimum value of this function into this domain. This will be here. So this is a circle. So this function take any value x comma y inside this circle, not into the boundary of the circle. This the function, the value of x comma y will be inside this, not on the boundary of the circle. So, so if you so what will be
Sir,
the
we
maximum
can
value?
see.
What will be the maximum value? Hello.
Sir, 1.
So this will be what? So if you taking 0 comma 0 at 0 comma 0, the value of function is what? Approaching to infinity, right? You can see that positive infinity. Hello. So
Yes, sir, we can see.
at 0 comma 0, the value of the function attend maximum, right? When x square plus y square is 0, this one,
Yes,
the value of function is maximum. And when the value of this function is minimum, and this one is at boundary, at this place,
yes, sir.
here.
This plane, it's look like a plane, na? So it is not
Yes, yes.
infinity.
Hello. No, no. At 0 comma 0, the
Yeah,
value
it
of
is like a plane, na? It's a plane, doesn't mean the infinity.
no, no, no.
Look
If
at the
you
Z value. That is going towards infinity. No? That's what it, Trusser
yes,
is trying to say.
yes, yes. The value of function is z.
No, I know that actually. That 0, comma 0, it went to infinity.
Yes.
And the xy plane also, it is infinity also going, right?
No, no. Which, so
Yeah.
suppose our function is in the boundary here. Forget this one thing. Forget this all the thing. Suppose this function, our domain is this circle. So,
Ah,
so this function will take only
okay,
this
okay.
value. This.
Okay, so it's a bounded function you're saying, right?
Yes, yes. The domain of this function is bounded.
Okay. Okay, got it now.
So here we have question: for which of the following choice of D the function is injective? So what is the definition of injective function?
One-to-one function. Every domain is merged.
One to one.
Domains. Yes. So what are the criteria for checking the function is injective? Means if the function is injective means what? If f of x1 is equal to f of x2, if and only if
X1
x1
equal
is
to
equal to
X2.
x2. So this is the definition of injective function. So the first option saying that if the value of x is 0 and the value of this is so this is the our input. If you take x equal to 0 and y is equal to y, such that y is equal to greater than 0. So this will be, if you take this as a domain, can this function will be injective into this domain? So take this function. And what are the input of this function here? So value of x is what here?
0.
So if just put 0 here, so put 0, we get y square, right?
Yes. Y will be 1, suppose.
And and here y is greater than 0. So this function will be injective or not?
Yes, sir.
Yes, yes.
Because this is, we get the graph of this function is like this. So the graph.
Sir, please don't go with the graphs.
Yes. So you understand, right? The algebraic.
Algebraic is better than the graph. We are not able to see in exams graphs.
Okay, okay. So this is increasing function, right? Basically this is decreasing function. This one, as we increase the value of y, this function will decrease, right? If you take when y tends to infinity, this value will be what? This is monotonically decreasing function.
Yes.
Hello.
Yes, sir.
And the second option said, if you take domain as x and the value of x as x and the value of y is minus y, such that x is greater than minus 1. So just put this value into this function. So if you put the value of x is equal to x and the value of this y is equal to minus 1, this is what we get. So this is 1, right? Plus 1. So this function is injective function or not? So just use this property.
Sir, it will be putting -1, no?
So here the value of y is minus 1, right? So I just square minus 1.
Okay, okay.
Here D is y x is greater than -1. So now we have to check this function is injective or not. So how to check this function is injective? Then so if
Not
you take
injective.
Every x
if
we
you
get
take
unique value.
hello.
Yes, sir.
So just find two x such that x comma y such that this function will break this property. Can you
X
able
is
to find
equal
such?
to -1 and x is equal to 1 are two x values for which
So
they will f of
x
x y
can
has same value.
yes, but x cannot take -1. So we just take x equal to 1/2 and y is equal to -1. This is x1. Take x2 is equal to -1/2. No. So if you put this value x1 here, the function value will be same, right?
Yes, yes.
Means this
Sir, but
function is not
y is
inject.
fixed to be -1, no, sir? How can we
Yes,
take
yes,
minus?
yes.
Okay.
Means if you put the value of function at fx1 and y is always -1, this value is equal to this value. I just take this value is equal, right? Means we can find such x and x1 and x2. This value are equal. Means this function is not injective.
Okay, so in questions like these, we need to just check for the counter example.
Yes, yes. We have to just find a counter example. And we have to just disprove. If you're not able to disprove this, you can say this is correct. Just we need to find some as example. Okay, I will take one example for finding the maximum and minimum of the function, finding the range. Hello,
Forward.
hello.
Yes, sir. Can you move forward?
Yes, yes. So the third option is the domain is defined like this. When we have x is equal to 1 and the value of y is 1, the value of y is y such that y is less than 1. So in this case, we have to check this function will be injective or not. So the domain is instead y is less than 1. So what will be here?
So it is 1
The,
comma y square, right?
so this is just put the value of x equal to 1 and we get this one.
Yes, we can take similar with the way which we did for x. Y1 equal to half.
Yes. So here y is less than 1. So just take y is equal to 1/2. So y1 is equal to 1/2
And the mine by 12.
and y2 is what?
Minus
Also
half.
on minus half. If you put this, this is also like this, right? So here x is 1. So these both are equal. Means this function is, can we say this function is injective?
No, sir, this is not injective.
This
So
so we
this
just keep
basically is, sir, excuse me.
hello.
Yes, sir. Sir, basically,
What?
by definition of injective is that for every unique value of x and y, we get a unique value, right?
Yes, yes.
Yeah, but here it contradicts.
Yes. Means two input has the same output, right? Here.
Yes, yes. This
And
is
the
what.
last option and the last option is like this this one, second and third one. Here y is not equal to 0 means y can take any value, right? So here if you take
minus
last option
one
y
and
can take, yes. So in this case this function will also not injective. Got it?
yes, sir. Can you, sir, also explain here bijective, surjective, and sum?
So,
Bijective.
is this recorded session?
Yes, yes.
So, where we found the link of this session?
um, okay, I just paste the link of the session. Okay, so can I move to the next question?
Yes, sir.
Sir, can you explain here bijective, surjective?
Okay, okay. So bijective means what? The function to be 1 1 and on 2 also.
Yes.
And here, so here I think it is, so I just take example. And x belongs to real number. So how to check this function is 1 1 or not? This function is 1 1.
Yes, sir, 1 1. For every value, we will get one value, unique value.
And how to check this function is on 2? Can means this function will take any output, right? For all input in real number, we get output.
Yes, sir.
So can we say this function is uh, bijective?
But
Means the
onto is it is not
the
onto.
no, this is on to, right? The output of this function is all real number.
Okay.
So can you? Okay, I'll just check another function. This one, x square. So this function is 1 1 or not?
No, yes, sir, it is
No,
on.
sir.
No, no, sir, because for two values of x we have x
For
square,
minus one, we will get one, and for one,
but
we
it is
will get
on to.
onto. It's
It
onto.
is on.
But this is not on also on to, right? This, so we have only positive. The output of this function will
Oh,
be
okay,
only
yes,
positive.
yes, yes, not on to, yes, sir, because we cannot have negative values. Not all
Yes,
real values are allowed here.
we are only getting r
Plus,
Negative or
r
positive or
yes,
plus
yes, yes.
or positive
positive. Yes.
means
So
not
this
even
function
on.
is not.
Neither on
This
one one
function
nor
is,
on.
yes. To just check is if the codomain is equal to range, then we say the function is onto, right? What are the criteria for the function to be onto? If the codomain is equal to range, then we can say the function is onto. So
On.
here, if the codomain, got it? This one, how to check?
Sir,
Hello.
just first one, fx equal to x. Can you explain with example? Like here, I am checking if I get fx minus one, we will get minus one for 0 0, 1 for one.
So
Uh,
what can we repeat? If we getting fx equal to minus x, right?
yes.
You're telling this function.
No, 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 no. For here,
Hmm.
fx equal to x. For value of x, we put minus one, one, or 0. We will get minus one, 0, 1, like this output.
Yes, here.
Yes.
So yes,
Every codomain has a pre-image exist. Okay.
yes. So suppose if we put minus one here, so how to do output? We get minus one, right?
Minus one, yes.
If we put zero, we get zero.
0,
If we
yes.
put one,
We will
means
get 1.
the output of this function is all real number, right?
All real number, yes.
So if the output is real number, then what? And the codomain is at what? The codomain of this function is also real number.
Okay.
So whenever we are getting the similar output and input, that
Okay.
will be bijective.
Yes. Okay, I did that like
It's
this.
not about input, it's about the codomain.
It's about
Similar part of saying domain and codomain.
No, no, we are not comparing domain with codomain. We are comparing the range of the function with the codomain.
Codomain.
range with.
Here, the function is defined from real number to real number, and the output of this function is all real number.
Yes.
And if output of this function is equal to this codomain, then we
Codomain.
said this function is onto.
Okay.
But in this case, so here this function defined from R to R,
Always
and the function
positive.
is, and this function, the output of this function will be always positive, right? All, so
Yes,
means
range will be always R plus.
we get 0, 1, 2, positive infinity. So means this value, so you are only getting the positive one, right?
Yes.
Means the output of this function is not equal to the codomain. Means near
Okay.
range is not equal to codomain.
Yes.
Yes.
So any other doubts?
No, sir.
So here we have function from R2 to R. We have function defined as follow. So where k belongs to real number and m is a positive integer. So the question is saying find the value of k for which f is continuous at 0, comma 0. So here we have to find the value of k for which this function is continuous. So what is the definition of continuity?
F of x is equal to
So,
the differentiation of x.
No, sir. Limit at 0, 0 is equal to f at 0, 0, right?
yes, means the this is definition. Limit of the function
X tends to 0.
0 is equal to the value of function at 0, comma 0, right?
Yes, sir. At f 0, comma 0.
Here we have to find at 0, comma 0.
Yes.
So if the I can just take here this also way. Means when we say the function is continuous, if the limit of function at that point equal to the value of function, then we say the function is continuous.
Sir, it will be f of a comma b, na, on the right side.
I just take
F of A comma B.
F of
RHS, sir, RHS.
RHS, sir, RHS.
we can also hear it. So first you have to find a limit, right? In the question saying find the value of k for which f is continuous at 0, comma 0. So first you have to find the limit of this function, right? X to the power m time y sine of 1 by x. You got this? What is the condition for continuity? Hello.
Yes, sir.
Yes, sir.
Yes.
So here x, if x is not equal to 0, we have function like this here, x to the power m time y sine 1 by x. Means the limit will be like this. When x tends to 0, we have to find this value. So what will be the limit here?
0.
Yes, the limit will be 0. So how limit will be 0? Can I write like this function? So here x to the power m can I write like this here? Can I write x to the power m as like this?
Yes.
So means if you add this two, so if you add the power of x, we get m, right?
Yes, sir. We can
Time
take
y.
that x in denominator as 1 by x.
Yes. And this is, so can I write this x as like this here? 1 by x. Hello.
Yes, sir.
Yes. Then
And
sin
now,
x by x.
so now put the limit. So tell me, if x tends to 0, this value will be to what? This value 1 by x.
1.
1, sir, 1.
No. I'm
So,
telling
so
if x
sine
tends
1
to
by x by 1 by x will tend to 1 when limit x tend to 0.
but here I'm asking here. So if x tends to 0, 1 by x is what?
Tends to infinity.
Infinity.
Yes. Means when x tends to 0, 1 by x tends to infinity.
Yes, sir.
So what is the limit here?
So there is a formula, na, limit extending to 0 sine of 1 by x upon 1 by x. That is 1.
Yes. And no, here this will be 0, right? This will be 0.
This will
Sine
be
1 by
0.
x.
X sin
Yes.
1 by x will be 0.
Yes,
Oh
yes.
yeah, the
Yes,
entire thing
Yes.
will
exactly.
be 0, but
Okay.
Your formula is right.
So 1 by x. Hmm, limit is. So if x tends to 0, 1 by x tends to infinity, right?
yes, sir.
So I just take this. I just take 1 by x equal to h. I just take 1 by x equal to h. Can I take this one? And now I rewrite the limit like this here. I just take 1 h equal to 1 by x and rewrite the limits. Limit this one like this. If s
H.
tends to infinity, if s tends to infinity, then 1 by x tends to what?
0, sir.
0, right? So this
Yes.
is same, right? This is same as this one.
Yes,
Yes,
sir.
sir.
So we can rewrite this line. We can change the limits, right? Limit condition.
Yes, sir.
So from this, what we get, and we know that the limits. So I just remove this. Can I write? I just take 1 by x equal to h,
Yes,
and
sir.
this is also h.
Yes.
Now I change the condition for limit.
It's
So what is the
tending to,
limit of this one?
so it's
Now
tending
what
to
will the limit?
infinity.
Yes, h tends to infinity. Now what is the limit? Sin h by h when s tends to infinity.
That is
0.
1.
0.
0. Sorry.
0.
Sorry, my mistake.
And the question asking for find the value of k for which f is continuous. Means the limit of this function when x tends to 0 is equal to the value of function at x equal to 0, right? For the function to be continuous. So what is the value of k?
0, sir.
0.
So the limit we get here 0, and the value of function at x equal to 0 is k. So we get k is equal to 0. Got this? And the second question is, using the value of k obtained in the previous question, find the minimum value of the integer m for which the partial derivative of this function at 0, 1 exists. So we basically have to find the minimum value for m for which the partial derivative of this function at 0, 1 exists. How to solve this? So tell me here. Here we know that limit, right? This one limit, sin h by h.
Yes, sir.
And this one. So basically you have to find the minimum value of m here for which the partial derivative of this function exists. So tell me what is the partial derivative of this function at 0, 1. This function.
It is basically mx to the power m minus 1.
So just use the limit formula.
So,
So for finding the partial derivative, we have this formula, right?
X
F of
plus h,
x plus h
x
minus
plus h.
comma y.
So just take here a minus f of a comma b.
a comma b.
And this is the formula for finding the partial derivative with respect to x, right? Now the question is, we have to find the partial derivative at 0, 1. So what will the value of a and b will be here?
0, 1.
0 and 1.
So this can be this. So now put this value f of h, 1 into this function, this one. And what is the value of f of 0, 1?
0.
0 itself.
0.
Because here x is 0. So if x is 0, the
K,
value of
K, K.
k is equal to 0.
K is 0.
Yes. So we can write this. So if you put this h of f of h, 1, what we get? So h to the power m,
Sine
the
of
value of sine of
1 by h.
1 by h. And this value is 0, right? This value is 0. So we can write like here. Write like this. So now we have to find the limit of this function. This. So what is the limit?
0.
Basically, we want to find the minimum value of m such that the limit of this function exists, right? Hello.
Okay.
Yes, sir.
So can I write this function like this here? Like this here. S into s to the power minus 1. Can I write like this here?
Yes,
So
sir.
h square, you'll have to take h square because in denominator we want 1 by h.
Yes, but
After this is
and we know that the value of sin h 1 by h. So the value of sin 1 by h is what? Oscillating between what?
1 and minus 1.
1 and minus 1.
Sir, sorry to interrupt. Sir, in this numerator, it is h into h to the power m minus 1. Okay, you have, okay, okay.
Denominator.
Got it, got it. You have divided and multiplied.
Got it?
Yeah, you have basically divided and multiplied, right?
Yes. So now if we if you divide this function here, what we get? Just right. One by h and limits this. So can I write this like this here? I just cancel out this h and write like this here.
Yes,
And we have
sir.
to find the, and we have to find the limit of this function, limit of this one. And here we know that the sign, the value of sign is between -1 to 1. And here we are using the sandwich theorem for finding the limit of this function
It will
when
be
s
0, no?
tends to 0. Yes. So basically we want to convert this thing into this one. So how we convert this into this?
Multiplying h raised to
H to
minus
the power m minus 1.
If we multiply s raised to power -1 and here also, we get this one, right? Now if limit s tends to 0, when the limit of this function exists, if you take the value of m is equal to 0, what we get?
1. Oh,
So h
sorry,
to the power
1 by
No,
h.
1 by h, no, sir. Minus 1 by h.
yes. So if you, so if you take m is equal to 0, so we get, if you take m is equal to 0, we get s to the power minus s to the power -1. So this will be what?
Minus
Minus 1.
1 by h.
-1 by h. And here also, here
1 by
plus
h.
1 by h.
1 by h. Yes.
If s tends to 0, the limit of this function exists or not? This one.
0.
No, no.
So minus
Oh, sorry,
infinity.
minus infinity. Minus t.
It does not exist.
Minus infinity. So the limit does not exist, right? In case of m,
Yes.
if you take m is equal to 0.
Yes.
Now take m is equal to 1. If you take m is equal to 1, what we get?
It is minus
Minus 1.
minus 1 to 1.
Minus 1.
If you take m is equal to 1, we get
Minus
-1 to
1.
Minus 1 to 1.
is limit exist?
Yes,
In
sir.
this case? No, because the
Sign
value of
change.
It
Yes.
this
oscillates,
is also
It oscillate
oscillate
between
between -1 to 1.
diverge basically.
And if you take m is equal to 2, what we get?
Minus h to h, sir.
Minus h square to h square.
So if you take m is equal to 2, this value is, we get h
Minus h
to
to
h, right?
h.
Minus h, sorry, sorry. To h.
And in this case also the value, this function is oscillating, right? Minus h to h, 0 to 0, right? Means limit also in this case not equal to not exist, right? In case of m
sir,
equals,
minus half to half, na sir. M is 2, no?
if
Oh,
you
sorry,
take m is equal,
sorry.
so Cochin is asking find a minimum value of, find a minimum value of the integer for which the partial derivative of function at 0, 1 exists. So if we are taking m is equal to 2, we are getting 0 to 0, right? In this case limit exists. Hello.
Yes, it is 0.
This is 0.
So whatever the value of m, the value of m will be 2, right? Thus, if you
Okay.
take m is equal to 2, then the partial derivative of this function exists at 0, 1. Got this?
Yes, sir.
So basically, sir, in
And
this type of functions, we have to use the sandwich theorem only, right?
yes, yes.
To check
Sandwich theorem will be easier.
if it converges or diverges. If it doesn't.
Yes, yes. So can I move to the next question?
Yes, sir.
So this question paper is from September 24.
It is on 22 or 24?
24.
Okay.
So here, so this, so here we have a function that defined from R2 to R. And the function is, the definition of function is this: sin square x plus cos square y plus 4y. So here the question is asking, for c belongs to real number, if gradient of the function at c comma c is equal to a comma b, then find the value of a plus b. So first you have to find the gradient, right? Then you have to substitute c comma c.
Yes, sir.
Basically, you have to find the gradient of this function at c comma c.
Yes, sir.
So tell me, what is f of x?
2 sin x into cos x.
So, so this is our function.
It is cos square y.
Okay, sorry. Now find the partial derivative with respect to x. So what will be partial derivative of this function with respect to
2
x?
sin x into cos x.
2 sin x.
2 sin x into cos x.
So basically, we are using chain rule. First, we differentiate this function
With respect
sin.
to sin x.
Yes.
Yes, sir.
So we can also write this function as like this, right? Square. So we first differentiate this function with respect to x. So we get 2 times sin x. Now
Yes.
we differentiate this function inside this. So the differentiation of sin x we get in cos x.
Yes, sir.
And fy will be what?
2 cos y into minus sin y. Plus 4.
Minus
2 sin y into cos y plus 4.
plus 4. Now to find the gradient of the function at c comma c.
Yes, sir.
So what will the value?
So it is basically 2 sin c cos c, which is sin 2c
So 2 sin c and cos c.
cos c,
And
comma
this value.
minus 2 sin c cos c minus 2 sin c cos c. Yes.
So this is our gradient of the function at c comma c. And this
Yes.
value is a comma b.
Yes, sir.
Now the question is asking, what find the value of a plus b. So a plus b will be what?
4. 4.
Yes.
Yes, sir,
So these two.
understood.
4.
So anyone has any doubt in this question?
No, sir.
Vishal is raising his hands, I think.
Sir, when will we go to the activity questions?
So which activity we have done?
Sir, um, I write it on the G form, sir. I have doubt in week 6.
Week 6.
Yes,
Can we discuss at the end?
okay, sir.
Yes, sir. Yes, sir. At the end, we will take all our doubts.
So, so this is our function, final function, this one. And the question is asking, choose the option for which the directional derivative at x comma y is equal to 0. So f of
Yes,
u means directional derivative at x comma y.
yes, sir. Basically, gradient, we took dot product of gradient with unit vector.
Yes. So directional derivative is what? What is the formula for directional derivative?
This is a gradient of x y to
Unit vector.
yes, unit vector.
So this is gradient of the function at s comma y dot product with unit vector.
Yes.
So we calculate this gradient, right? This one is a gradient. So now put when x in first of all saying if you take x equal to pi by 2 and y is equal to 0, what is the gradient?
It is basically 0, comma 4.
So if you take this one, gradient of the function at pi by 2 and 0, so sine 90 is what?
1.
Sine 90 is 1
Cos
and
90
sine
is 0.
and
Cos
cos
90.
0 is what?
Oh, sorry. Cos 0 is 1. Yes, sir.
I think
Cos 0 is 1.
so sine 90 is equal to
2
this,
into
this
2.
y. So what we get here?
2 comma minus 4.
2 comma minus 2.
4 4. 2 comma 4.
So sine y
Sine
is what? Sine
sine
0 is
0
what?
is 0, na, sir?
Yes, sir.
And cos 90 is what? No, cos 0 is 1, right?
So,
You are putting both to
sir,
y.
Hello?
Yes,
I,
sir.
I think here we did mistake here. This
Yes, sir.
thing. Now calculate this one. Sorry for this.
again,
Sir,
sir,
sine
This will
0
2
is 0.
comma 4.
0. So 0 and this will be 0, right? Sine
Yes, sir.
Yes.
No,
and
sir.
this thing.
Okay. Sir, in first term, cos x will be cos pi by 2, that is 0. So it becomes 0. For
Yeah.
second term, our cos y will be 1. So sin y will be 0. Sorry.
Cos
Yeah,
90.
sin 0 will be 0. So again, it will be 0 plus 4.
Sir,
Sir,
sine 0, cos 90 will be 0.
So sine 90 will be what?
Sine
Sin
90,
0 into cos 0 it is, no? Because y term, both
Yes,
are
yes,
taking y.
yes. Sine 0 is
Sin
0.
0 is
Yes,
0, sir.
yes,
sine 0, 0, sine 91. And cos 0,
yes.
1, cos 90, 0.
Means sine 0 will make this whole term 0. We are
Yes.
getting 4.
4. Yes, sir.
So unit vector is given. So gradient is 0 comma 4.
Then we can just, in the earlier part, we have just already cancel out the terms also, no?
Where?
No, no.
So gradient is at pi by 2 and 0 is 0 comma 4
It is
and
1,
unit
comma
vector is
1,
1
comma
comma
0.
0. The dot
0.
product between these 0,
0.
right?
Yes.
Means the first option is correct. Like this, we have to also calculate the second one.
Yes,
Sir,
sir.
is it okay? That was you one. Okay, fine.
This is
Sir, this
hmm?
U is norm now.
This u. This is u is unit vector.
Unit vector. Unit
Yes.
vector is calculated by the norm.
Yeah. Suppose here if a vector this one comma two. If this vector is unit vector, how
No,
to
sir.
check the?
No, sir. If we divide by its
No, this
norm,
is
then
a,
it becomes unit vector.
then it will become now.
So
So
one
to
by
make
mod of
this
comma two.
to make this unit vector, we have to divide this vector with its norm.
Yes, sir.
Yes, sir.
So norm of this vector is what?
Five, sir. Root five.
Root 5.
Root five. Yes,
Yes.
sir.
So just divide. Um, this is unit vector now, right? Just find the norm of this vector. We get one. We find this. So norm of u is one. So this is unit vector. Basically, we change this vector into unit vector. Got this? No.
Yes, sir.
And the second option we can also check, right? Like this, the first we do. So we have to just substitute the value of x and y here, and then find the gradient at x comma y. Then just we have to do dot product. And which of the at which x comma y the function this value will give dot product 0, then this will be true, right? Hello.
Yes, sir.
So can I skip this part?
Yes, sir. Yes, sir. You just keep that.
So consider the scalar value function f of x comma y is equal to x sin y plus y cos x, defined on R2. Since the domain of this function is R2, let a comma 3 comma b a point that lie on the tangent line to the graph at 0 comma 0 in the direction of steepest ascent. So what do you mean by this?
So it basically take maximum value of fu in
So the
that
question is
direction.
saying, yes, the question is saying let a comma 3 comma b be the point lying on the tangent line to the graph at 0 comma 0. Means this point lying on the tangent line to this graph in the direction of steepest ascent. So first you have to find, for solving this question, first you have to find the direction of steepest ascent. So what will be the direction of steepest ascent for this function?
It is basically gradient and
Gradient at
geometry
norm.
by mod of that gradient or norm of that gradient.
So first you have to find the gradient, right?
Yes, sir.
So what is the gradient?
So it is basically different.
Sin y
Yes.
minus
Sin y minus sin x.
y sin x.
And
Yes,
just what
yes.
will be the partial derivative with respect to y?
It is basically x cos y and cos x plus cos x. Yes.
So this is partial derivative with respect to x and partial derivative with respect to y.
Yes, sir.
Now for finding the direction of steepest ascent at 0 comma 0, so what you will do now? You
Sin
just
of
substitute
0.
and what is this value? Sine of 0 is what?
0, sir.
And y times sine x, what
Again
this value?
0.
0.
So
And
this
this
will
is
be power of
again 0. So it is whole 0 comma 0. Right? No, no.
no
0 plus 1. Yes.
0,1.
0 comma 1.
Mhm.
0 comma 1 we get.
Yes, sir.
So this will be 1. So
So
gradient of the
x
function,
plus Okay, x is 0. Correct.
So the direction of steepest ascent is basically the direction of gradient, right? When you move along the direction of gradient, so the direction of gradient is the direction of steepest ascent, right?
Yes, sir.
And this steepest
Sir,
ascent is
this
hello
y cos y is given. Cos y is also no 0.
cos
That
90
will
is
be
0, right?
0 now. Yes,
Hello.
cos 90 is 0. Then plus
No,
cos x is given. Cos x is also 0. Then there's 0 plus 0.
Cos 0 is 1, na?
Oh, okay, done.
cos 0 is 1. When cos will be 0 if theta is equal to pi by 2, 90 degree. So now you have to find the direction. Hello.
Yes, sir.
So what will be the direction of steepest ascent?
So first we have to take the norm of gradient at 0, comma 0, right? To get the steepest
Yes.
extent.
Norm is
Yes.
1 no, already.
Norm is 1
Here
only, na?
norm is already 1, right?
Yes, sir, it is already.
Norm is 1.
Yes. Here if you find the norm of this vector, this is 1, right?
Yes, sir. So basically our steepest extent is 0, comma 1, right?
Yes.
Yes,
Yes.
yes.
Now the question is saying let a comma 3 comma b be the point lie on the tangent line to the graph of this function at 0 comma 0. Basically it is asking for find a
Okay.
tangent line tangent line
Yes, sir.
at 0 comma 0 in the direction of this vector, this steepest ascent, direction of the steepest ascent. So how to find the equation of tangent line?
So we can use parametric form for this.
We can also use this one, not this one. Basically this is what
Yes.
a comma f of a comma b plus, so this is e1 and this is f2. This is also right.
Yes, sir. So it is parametric form, no?
Yes.
Okay.
So what are the value of a and b and f of a comma b here?
So it is 0, comma 0, and f of a comma b is
And f of a comma b is what? F of 0 0 0 is
0,
what?
comma 0. Yes, sir. It is again 0.
Plus t times. What is e1 here?
So it is
0,
0, comma 1.
1.
And this thing.
So we have to find, I think, this thing.
So you have to find this one.
Yes, sir. Dot product with 0, dot 0, right?
Yeah.
Yes, sir.
Basically this is what
0.
directional derivative.
Yes, sir.
0.
So,
0 itself, it is also.
so this value is what? First you have to find a gradient, right? Gradient at 0 comma 0.
It
Into
is 0, comma
u.
1, dot u.
And what is u here? Basically this is u is steepest direction, right?
0,
Steepest
comma
ascent
1.
at 0 comma 1.
Yes, sir.
So what we get?
0, sir.
No. When so
1,
this is
na?
0 comma 1.
Sir, 0
0,
dot,
delta
So
of
this
0,
is what
0 is
yeah, got it, sir.
delta is 0 comma
0, 0
also
1, na? So we'll get 1.
we get 1.
Sir, getting confused. Can you please explain it again, sir?
So here basically we have to find a tangent plane, tangent line at 0 comma 0 in the direction of steepest ascent. So here
Yes.
means here our unit vector is what? This direction of steepest ascent, right?
Yes.
So we find the direction of steepest ascent, this one, this 0 comma 1.
Yes.
The direction of steepest ascent is 0
You
comma 1.
can write u itself.
So basically that becomes our directional vector.
Yes. And for this is what we said, this is what the
Directional derivative.
directional derivative at 0 comma 0 in the direction of this vector
0 comma
Unit
1.
vector, yes.
0 comma 1. So we know this value, this is 0 comma 1,
0 comma 1.
this u is 0, also 0 comma 1, so dot product between these two vector will be 1.
Yes.
And so this value will be what, fu of,
Yes, it will be 1.
1, sir.
0 dot 0 comma 1 dot 0 comma 1. Okay. Yes.
and we know this value, right? This value is what given.
A3B. Then we compare from it. Yes.
So what will the value of a we get?
B is equal to A is equal to 0, sir, and B is equal to
So I just writing from a,
T is equal
A is
to
equal
T.
B.
T equals
so
to
B is
T.
equal to 3 also. Yes,
3
sir.
time 0
U is also
1
0.
1, and the value of a we get 0,
0, sir.
and the value of t we get,
3.
3,
and the value of v we get.
3.
So b is equal to t, right? And we
Yes,
know
sir.
t is equal to 3.
Which is equal to 3. Yes, sir.
And the question is asking, find the directional derivative of f at point 0 comma 0 in the direction of steepest ascent, and we know this value is 1.
Yes,
This
sir.
thing.
Sir, can you just repeat what you said last?
So the question is asking, find the directional derivative of f this at point 0 comma 0 in the direction of steepest ascent. So
Yes,
what is
sir.
this
So
value?
it is
We
FU,
just,
no?
yes,
We
this is
have
same.
already calculated. Yeah,
Yes,
this is
yes.
Yes,
fine.
yes. And find the value of a. So what is the value of a here?
0, sir.
No, yeah.
Yes, sir. 3.
And
0.
the file,
Sir, but
and the file.
sir, please can you move above a little bit? Here the problem is A is coming out 3.
No, a is coming out with
No, yeah, 0. But 3 is coming here and 3 on the other side. But 3 is coming Y. Like,
t is equal to b is given. So just we
is
just
there
compare
any,
this value.
is the value of T given as 3?
No, no. So this is the equation of tangent line, right? We know that,
Equation is understood.
and it
The
also and
last,
okay, okay.
why we
So
have
this,
taken T as 3?
So
okay.
basically, we compare the coordinates. That's
Yes, so we basically comparing. So if I take t inside into this vector, this will be what, t times this will be. You understand this part? So,
Yes, A3B, A3, 3 coming out.
so we just compare this. So here we have 0 and here we have a. So value of a will be what? Just compare this. So value of we are getting 0. And here we have t, and here we have 3. So t will be what? T is equal to 3. And here we have also t is equal to b. And we know that the value of t is equal to 3. So we can substitute this value, apply v is equal to 3. Got this? Hello?
yes, sir. We can.
Yes,
We just comparing here, left and right hand.
we are comparing understood. But
Yes.
3 coming between
Basically, t is equal to what? T is equal to 3.
like A3B has computed as the tangent lines.
No, this is the equation of tangent line. Got it? This one, this part.
Yes, this is understood.
And this value is equal to this one.
Value, if we get that, then the value should be 0 tt.
0 tt. This one, yes, 0 tt. Yes,
Yes,
here we get it.
yes. Then why we have compared A3B? That is the
Because
main issue.
they are point on the tangent line. It's written
So
mentioned. See,
Oh,
in
that's
the
that
why.
is
question it is
mentioned.
mentioned.
Oh,
Yes, it
understood,
is
sir.
mentioned in the question.
Very well, sir. Very well. Thank you so much, sir.
So we just get the value of h equal to 0 and the value of b is equal to
Let's
3.
take another question.
Got this one? Anyone has any doubt in this question? Can I move to the next question?
Yes, sir.
So here we have function f of x comma y is equal to cos pi x square plus y square defined on R2. So
So we
how
can.
many critical so
Yes, sir.
how many critical point does the function f has? So how to find the critical point of this function?
So basically, put partial derivative equal to 0.
Yes. So means and we know the graph of cos x, right? Cos. So
Yes,
graph
sir.
of cos is what? It oscillates between -1 to 1, right? So
Yes, sir.
from graph we can also understand there is multiple infinitely many points where the slope will be 0, right? So
Yes,
graph of cos x is this
Yes,
like
yes.
this one. Means
yes,
there are infinitely many points on the domain, so slope will be 0, right?
yes.
We also compute algebraically.
So we can skip that, I think.
Can I skip this one?
Yes, sir.
Other?
This
Hello?
graph is critical point finding is this by derivatives, putting it to zero.
Yes.
So, so
Yes.
can we
First,
go with the gradient formula?
yes, yes.
Just
So
find
compute.
we'll just find the partial derivatives and equate the gradient to be 0. Can we do that?
Yes, yes. So what will be the f of x?
So it is basically cos pi x square plus y square into 2x.
So first we have differentiate cos, right? What we are getting?
Minus
Cos of.
sin.
Yes, sir.
Minus sine pi. X plus of x
Pi
Pi times x square plus y square.
into 2x.
into
2 pi x, no?
2 pi
2 pi
x.
x. Yes.
Sorry, 2 pi x. 2 pi
Yes.
x.
And f of y will be in seed symmetry.
Yes.
So here what will be what?
Basically 2 pi y,
Y.
yes.
2 pi y. Got this one? How we find this one?
Yes.
Partial derivative.
Yes, sir.
Just now we have to equate this equal to 0, right?
Yes, sir.
And tell me, so this quantity will be, we have to calculate f of x equal to 0. Either here, from this, what we conclude? Either
X
x will be
is
0
0 or x square plus y square is 0.
or
X square
this will
plus
be
y
0.
square is 0. Yes, yes.
And when the this is sine, right? When sine x is 0,
When
And
x
it's
is 0 or multiple of pi.
this means sine, the value of sine will be 0 when the value of
Sine
theta
of
is what? So here, just
mm,
I just take this value as a k. Suppose I just take this value as a k. So I just take k is equal to this value. let's take this k. So when sin k is equal to 0,
Odd.
k, if k is equal to n pi, right?
Oh, any
This will
oh, sorry,
Yes.
sorry.
n belongs to any integer.
Yes.
Yes.
Means we are getting infinitely many points, right?
Yes, sir.
Yes.
Yes. Got it.
So here n belongs to any integer means we have infinitely many integers. So
Yes, sir.
there will be many critical points for this function.
Got it, sir. Got it.
And this is same.
Yes, sir. Yes, sir.
Can I move to the next question?
Yes, sir. Yes.
Yes.
So the question here, what can we conclude from the Hessian test for the function
Sir, why we have written n here?
n?
Yes, why we have computed to n?
So when sin k is equal to 0, when will when the value of sine of theta sine of k will be 0? If theta is equal, if the value of k will be n pi, means the value of k will be multiple of pi. Hello.
Yes, sir.
Sir, basically it is from trigonometry, right? I
Yes,
think
yes, yes.
he does not remember that.
So remember this thing. The value of sine k will be 0 when k is equal to n pi, means the value of k will be multiple of pi. So sine, when sine will be 0, sine 0 is 0, right?
Yes, sir.
Yes.
In this
Yes,
case,
sir.
it is
At 0
continuous.
at pi and I will next.
Hello.
Yes, sir.
Yes.
Got this one? Why you are getting k is equal to n pi?
Yes, sir. You can move forward.
Yes, we have seen that is sine k is equal to 0. So 0 is one of the answer, or n pi is other answer.
Yes, mean n belongs to any integer, means we can take pi. Sine of pi is what?
0.
Sine of pi is 0.
0.
Means sine
Right.
of 2 pi is also 0.
Hmm.
Yes. And this is question. What can we conclude from the Hessian test for the function f at 0, comma 0? So
Sir, we can
basically we have to check.
double derivative with respect to x and y at 0, comma 0,
Yes.
right?
Basically
Yes.
we have to find a
It's
Hessian. Hello.
Hessian matrix.
Yeah.
Yes.
Basically we have to check 0, comma 0 is what? It is local minima, a
Max.
saddle point, or it is. So what do we have to do now?
So we have to take compute f of x. I mean double derivative of x.
For Hessian
You have to
test
find
for
the Hessian
function at,
matrix. No?
yes, yes. So finding Hessian matrix, we have to calculate fxx, right? This
Yes, sir.
quantity.
F of x f of y.
What we get if we include
It
this?
is basically minus 2 pi sine pi x square plus y square.
I just copy the function here. And what is the function? Cos.
You can write fx and fy. Sir. It would be easier for calculating both.
Where?
So I said if you can write fx and fy, it would be easier for calculation.
yes, sir. Because we want fx.
Yes, yes.
So you can copy from above, no?
Try both.
Hello.
Yes, sir.
So now compute this one. Partial derivative of x with respect to y. Now first compute this one. So what will be this value?
It is basically minus 2 pi sine pi x square plus y square.
Can I take minus common here from this?
Yes, sir. Minus 2 pi you can get common.
Yeah, we can also take y common.
Yes, sir.
Now differentiate this function with respect to x. So this
It
is
is
what we
basically
get. This,
sine pi.
So there are two.
so what we are getting? Yes, two is also here. So this thing. So this is what? This is
1.
u time
Sine
u time
sine
b.
pi of x squared plus y squared.
You have to apply product rule, right?
Yes,
Here.
sir.
So differentiation of x is what?
1, sir.
One. Then we have to no.
Right
This is
sine pi.
yes.
Sine pi x square plus y square. Then we have to differentiate this whole thing again. Yes, sir.
Yes. This thing
In,
into.
into yes, sir. Sine
So
cos pi
this is
x
what?
square plus y square into 2x. Right.
So shouldn't it be plus y into
Yes. Yes.
plus plus?
Yes. Yes. And
Yes.
this you have to differentiate this now, right?
Yes, sir. Cos pi x square plus y square.
Pi x squared times of value x squared plus y.
You can write 2 pi x into 2 pi x square. It is basically.
So we have basically differentiate this. To differentiate
Yes.
this, what we get? So cos of
Yes. 2 pi x, sir.
2 pi x squared.
2 pi
X.
x.
Yes, sir.
This is our f of x. X.
Yes, sir. So it will be more complicated.
For this
Yes, sir.
and
So
f
you
of
can
y.
put the value here also. It is 0 comma 0, no?
Yes. Yes.
We can take the value here only, sir.
0, yes, sir.
We will get 0 only.
So this value will be zero. Sine of
0,
this
yes. Sir.
zero,
And
and
cos
if
of
x
0,
is
0,
so,
yes, sir. Again 0.
so this will get zero.
Yes, sir.
And f
Same,
of
same will follow for yy also, sir.
yeah, this will be symmetry, right?
Symmetry, yes, yes.
Yes.
So the main difference will be here. Right? This will be
Y cos.
Sir, with here itself you can say the test is inconclusive because f of x is 0, right? X is 0.
yes.
Then, yes.
And now calculate this one. Complete this question. So this will be what? F of x comma y.
F of xy would be, where it is.
So what
It
is
is basically cos.
I can write 2 pi
Yes, so 2 pi you can take common.
times cos
Pi x square plus y square. X square plus y square. In, yes, sir,
y square
into 2
pi
pi y. 2 pi y.
2 pi y.
Yes, sir.
And this value is also zero.
Yes, sir. It is again. So then the whole determinant will be 0, right?
Yes.
Yes, sir.
Now
Then
Hessian matrix will be what is
2
so
cross
this
2.
this value will be what fx x, right?
Yes.
And
F
this
of
thing is
x.
zero.
Yes, sir.
This is the zero matrix. No?
And this is also zero.
0, yes, sir.
And so determinant of h.
Into 0.
So it is inconclusive.
Yes. Test is inconclusive. For this one,
Sir, sir, what if we get a case in which we get fxx as 0, but the determinant is negative?
if we get means here we
Yes, yes. Here we are getting 0. I'm just saying. And but the determinant we get as negative.
yes. So
In
we are
that case,
telling
The answer saddle point is the answer, right?
saddle point, right?
we are, if we are telling here fx is equal to 0
Yes. And the determinant is
and
negative.
determinant is
Because I think from fx, if fxx equal to 0, then at that point only we are telling it as inconclusive, right?
so means if determinant you're telling determinant is not equal to 0, right? So
Negative.
negative, yes, means
Negative.
not equal to 0, right?
Yes,
Can you
yes.
say
Yes, not equal to 0.
means what?
Yes, sir. In the rule, it is given that whenever the determinant is less than 0, we say that it's a saddle point.
Yes, yes.
Yes, yes, yes.
Yeah, you can also write less than 0 means this is
Saddle
saddle
point.
point.
Yes, sir. Whatever be the value of fxx,
Yes,
it doesn't matter.
and in case of suppose we have three we have 3 cross 3 matrix, Hessian matrix.
Yes.
So in case of if determinant is not equal to 0 means what we can conclude in case of 3 cross 3 matrix, say Hessian matrix.
For that, we check.
Then we'll have to check 1 by 1, 2 by 2, and 3 by 3, the signs, right?
Yes, plus,
Yes,
plus,
yes,
plus,
Plus, plus,
minus, plus,
plus,
minus.
minus, plus, minus, that thing we'll
Yes,
have to.
yes.
yes.
So in 3 by 3, if it is less than 0, then it's a saddle point, right? Determinant is less than 0.
No, for saddle point in R3 you have to check if determinant is not equal to 0
Got it, got it, got it.
and
Got it,
there
got
is
it.
also
There is other condition also, yes,
Other
sir.
condition.
yes, yes,
Okay.
the first and second condition is also not satisfying and determinant is not equal to 0, then
So
in case of this we
for
can
3 by 3, basically we'll have to check at not equal to 0. And if it is equal to 0, then it's inconclusive.
yes, yes.
Thank you.
Here question is saying let T with the linear transformation from R2 to R3. So the linear transformation with range space of T is given by W is equal to a span of this 3 vector. So so this linear transformation, the range of this linear transformation is a span of this 3 vector. So what do you mean by a span of this three vector? Range space of T is a span of this 3 vector. Means what do you mean by this?
It will cover entire R3. It's a
So
basis.
from this information, can we find the transformation matrix of this T?
Yes, sir. So by using a standard order basis, you can find.
Yes, suppose here the let's look at the question. The question is saying let A be the matrix representation of T with respect to some order basis for both domain and codomain. Then which of the following is correct? So from this information, can we find the transformation matrix with respect to a standard order basis?
Yes, sir, you can use TF
Suppose
100 plus.
So it will be 131 no, for the first one.
So it is 13.
so, so first look at here. The question is saying the range space of T is a span of this 3 vector. Means the range of this linear transformation is linear combination of this 3 vector, right?
Yes, sir.
Means
Yes.
means the output of this linear transformation will be just a linear combination of this 3 vector.
Yes, sir.
So from this information we can find the transformation matrix. We can this just
131,
put
131
131
20 minus
minus
20
minus 1. minus
-2.
2 2.
And this is, suppose this is our transformation matrix. And this linear map is from R2 to R3. So what we are saying, this the output of this matrix, this linear transformation will be just a linear combination of these three vectors, right? Hello.
Yes, yes. X, Y, Z, right?
X
Sir,
was
sir, it should
Yeah.
be 3 cross 2, na, sir, the transformation matrix.
Okay, okay, yes, yes. I think,
Cross 2, right? So,
okay, okay.
yeah.
First, here, so here we have to find the basis for this span. So independent vector, this one. We have to find which vector is independent.
Okay, sir.
Means, to tell what will
The
be the
first
term.
and third will be independent, and the second one will be dependent, sir.
Okay, first. So what will be the order of transformation matrix?
3 cross 2,
Three cross.
3 rows and 2 columns.
so 3 cross 2, no, sir?
Yes, yes, 3 equals 2. Now we have to find which of the following vector in this is independent. How to find
So
which?
A times this one vector plus B times this is equal to 0, comma 0.
Can I, yes? Can you use RREF method?
Yes, sir, you can use
Yes,
that.
sir. Yes, sir.
It's -2. So how to make this thing? So for finding which vector is independent, so what to you just use RREF, and if
Yes.
Yes.
if the column contain the pivot element, that column will be what? Linearly
Independent.
independent.
Yes.
Linearly independent.
So we have to make this thing zero, right? So how to make this thing zero? This element
3 times R1 minus R2 is
R2 is equal to
3 times R1 minus R2.
3 times
R1.
R1.
So,
So this thing will be zero, and this one
so it is 0 minus 6. Minus 6.
Minus 6, and last one will be 8. Last column.
Sorry, here can we write 3 R1 minus R2 or not?
where
So here R2 is equal to. Can we write 3 R1 minus R2?
Sir, at the same step, we can also do R3 as R3 minus R1. Then we'll directly see that, R3 and R2 are multiples basically.
yes, yes.
We'll get minus 3 and 4, 0 minus 3 and 4 in the
Mm-hmm.
output.
-1. So this this is one. I think
Then we can simply do
2 0 -1 -2. So what you are telling?
so we can do R3 minus R1 and R2 minus 3R1.
R3 minus
R3 minus R1. R3 is R3 minus R1.
if we
And
do
R,
R3 minus,
yes, R2 is
what we
R2
get?
minus 3R1.
So this will be what? R3 minus R1 we are doing, right? This will
Yeah.
be
0, sir.
0 minus
and this
3
is
minus 3 4
and this thing
4.
4.
Then
and this
And
thing.
the second row will be 0 minus 6
minus
8,
6
sir, as we had done earlier, sir.
Yes, yes. So R2 is equal to R2 minus
3R1.
3R1. So this will become 0, and this we are getting, what we are getting here? minus of 6, right? And this thing we are getting 1, 8. And these two are multiple of each other, right?
Yes.
Yes.
Yes, sir.
So we can just divide this. We
Yes.
can make this
We can make this
0.
3
0.
minus 2 are
Yes.
half.
Minus 2
So
R2.
we just divide.
Yes, sir.
So
Got it. Got
if I divide by minus 6, if you divide by minus 6, what we get? 1.
One
it. 1
And this quantity
minus 8 by 6
4 by 3
minus
minus 4 by 3.
minus.
minus 1
So,
So we just needed the vector, na, sir. So first
mhm.
column and second column is what we need.
minus 1 is 3.
So means first column and the second column are linearly independent column.
Yes,
Yes.
sir.
Means these two vector are first and second are linearly independent.
Yes, sir. Yes, sir.
And the basis for range of T is this one, 1, 3, minus 1. So this is the basis for range of T, right?
Yes, sir.
And we just, and this is a suppose this is a transformation matrix A. Now put this vector as a column. Means the output of this linear transformation will be just a linear combination of these two vectors. What this part? Why you are doing this?
Yes.
Yes.
Remember, range space is also in some we say range space is equal to also say column space,
Yes, sir.
and range also, and we also say range is equal to images, right?
Yes.
So if let A be the matrix representation of T with respect to some order basis for both domain and codomain, then which of the following is correct? The columns of A are linearly independent.
True, sir.
Yes.
The rows of A may not be linearly independent. Can this possible?
False.
So it means the rows of A may not be linearly independent. Dependent, sorry. So it can be dependent, right?
Okay.
Yes.
Just
Yes. 3
Yes.
are
Yes.
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 correct. Correct.
And the nullity of A is 0.
Okay, sir.
Yeah.
Nullity, nullity is what?
Right.
But okay.
Nullity is number of free variable. How
Yes.
many free
0.
variable we have? We have
Yes.
0, right?
No free variable.
No free value.
Sir, why we are just we have to just check on the basis part of the
Yes, yes,
nullity,
yes, yes. So
not
nullity.
the three vectors we are given. We have
Yes, yes,
computed a really well definition. Nullity always defined in the linearly independent cases.
yes. Nullity means linearly independent variable means free variable. No, no, sorry. Nullity means
The basis vectors are only considered for nullity.
yes, yes,
So we can equate the transformation to also 0, 0, na? T of xy.
yes,
Then also
yes,
we will
yes,
the null space solution.
yes.
So didn't get the point, sir. What?
Hello.
No, like this transformation part, right? Like x plus 2y, 3x, and x minus y. So
Mm-hmm.
even if we get equated to 0, 0, so we'll get the null space only, right? So
So for finding nullity, nullity means what? The set of all. Nullity also say we kernel, right? Kernel. So just take nullity. Nullity is the set of all x such that
AX is
x
0.
equal to
x equal to 0.
0.
Mm-hmm.
Just do REF. If you do REF, how many dependent column you get?
Sir,
Two, both are
uh,
independent.
Hello.
so this is a full rank matrix.
Yes, this is. So this is not full rank matrix. The rank of this matrix is 2,
Yes.
and the color row rank is
This
also
is
2.
not a full rank matrix.
So when
Full
we say
rank is
the matrix,
associated with square matrix.
Square
yes,
matrices.
it's square matrix. So this is rectangular matrix, right? Hello.
Yes, sir.
One
So we
thing more,
find the
sir.
value of
One thing
x.
more. One thing more. If we are computed 3 into 2 matrix, then the rank
Hmm?
should be 2.
Yeah, rank is 2. Here just find number of independent
Then,
vectors.
then where is the rank nullity theorem applies only on square matrices?
No, rank nullity theorem applies to any matrix.
Here rank is 2 itself.
Rank plus nullity is total columns. No, total columns is 2. Rank is 2. So nullity
Yeah.
is 0.
Here the rank nullity I think is satisfied.
Yes,
So
yes. It
just
is satisfied.
rank
Nullity is 0 na here.
Nullity is 0, na?
nullity is equal to the what is rank per nullity is equal to number of columns, right?
Columns.
So here rank is what?
Those
Both
columns.
columns are linearly independent, right? We just find here. So means rank is equal to 2. If rank is equal to 2, what do we comment about the nullity?
0, 0.
Zero.
So nullity is 0.
Is 2.
So, so this will be correct.
So,
Nullity of A is.
sir, we
Hmm?
were doing that ax is equal to 0. Sir, so when we say nullity is x such that ax is 0, so in this case, sir, how would we proceed to find that x, sir?
So just augment this matrix with 0 0.
For ax is equal to 0.
Now
And then
perform
find the value of x1 and x2.
yes.
Sir, then what actually in this case, I think it will be 0 and 0.
So x and
Yes,
y will
yes.
be 0.
0 and 0,
The
correct.
solution and the
What
dimension
is
of
the
0
solution for this? What is the
this one.
solution for this? Is this having a
This
unique solution?
okay. So if you solve this system, we get the value of x and y will be 0 comma 0. The solution for this system will be this 0 comma 0. Means this is nullity, right? The null space contain only this vector.
Yes, 0 vector.
Null space contain this vector. The vector will be 0 comma 0. And what is the dimension of this null space? 0, right?
0, yes, sir.
0.
And the dimension, and we say nullity is what? Nullity is the
Dimension
nullity
of
is
null space.
Null space.
Dimension.
hello.
Dimension is.
Yes, sir, you
Dimension
got
is.
your point.
So dimension of null space is nullity, and here dimension of this null space is 0. Got this? Hello.
Yes, sir. I'm asking. This is a unique solution.
Yeah, this is unique solution. Now we exactly have only one solution, 0 comma 0. 0 comma 0 is the only solution for this system. Hence unique solution.
Okay. So let's move on to
Suppose
next concept.
so the fourth option saying the range of A form a plane in R3. So forming plane in R3, how many vector we need?
3.
No, 2, right? Plane is a two-dimensional subspace of R3, right?
Plane is of taking in like XYZs. R3s are possible.
So tell me what is the dimension of plane in R3? Suppose this this is plane, right? This is the equation of plane in R3. No.
Yes, sir.
Yes, sir.
Yes, sir.
For spanning any plane in R3, we need two linearly independent vector. That
Yes, sir.
so the range of A is what? This two. The range of the span of,
Independent vector. Yes, sir.
so
Two
the
linearly
span of this, so the span of this two vector will be what? Plane in R3, right?
Yes, sir.
For a spanning plane in R3, we need two linearly independent vector. So got this one?
Sir, getting confused, sir. We have got two linearly independent vectors in R3,
Mm-hmm.
and now we are trying to say is those two linearly independent vector are spanning a plane in R2 or R3.
R3. We have R3. So okay, I will tell
So
you
for
how.
R3, we'll need three
No,
components
no,
in the vector,
no,
no,
no.
sir? So we need three vectors for that.
That would be solids, I think. That did not be plane if you take three vectors.
If you take three vector means we have we span whole R3.
Yes, sir. Yes, sir. To span
So
entire R3, we need
let's look
three
at,
vectors.
okay. So here let's solve this question. So this basis for range for this linear transformation, this one is this two vector, this two vector. And what will be the span of this two vector?
Okay.
What will be the span of range of T? So this is range, right?
Any linear combination of these two vectors.
So if you take the linear combination of these two vector,
Mm-hmm.
8 time this one, we
Yes,
get
sir.
this one,
Yes,
right?
sir.
And we can write this is x, right?
Yes,
We
yes.
can write x equal to 2a plus
Yes, sir.
3b,
Yes, sir.
y is equal to a,
Yes.
and z equal to a.
Yes.
And we can substitute the value of a here into
Mm-hmm.
y, right? We just substitute this value, and here we can also substitute
Okay,
the
sir,
value of this,
understood. Hmm.
and we get the plane. So
Yes, yes.
span of span of these two vector is just a plane in R3. So we can remember, so we can say that. So if you want to span a plane in R3, we just need two linearly independent vector. Got this?
Sir, we got those two vectors.
Hmm?
Then what we did was we wrote x in terms of those two vectors and y and z in terms of those vectors. Now we
Hmm.
take those equation and substitute in the equation of plane which was given to us.
Where plane is
No,
given?
no, I'm asking, sir, is it what we are doing?
Yes, yes. So we just write the linear combination of these two vector.
Yes,
Then we just put the this value, we substitute this value is equal to x.
yes, sir. That part is done, sir. After that, just below
After
that,
that,
x is equal to.
so here we just do substitution. This we just substitute the value of a into this equation. If you put the value of
So
a, we
this
get,
equation where it is written x is equal to 2y plus 3b, is it given to us already?
no, no, no.
Mm-hmm.
So I am telling this is basis for range, right?
Correct, sir.
Basis for range of T.
Yes.
And the question is asking what will be the span of this T? What will be
Okay.
the span of range of T?
Okay.
Range.
Mm-hmm.
Range contains these two vector.
Right.
And we want to find the what will be the span of these two vector.
Yes. Sir, what is that
Span,
equation given? X plus y minus z equal to 0 and 2x plus y equal to 0?
this is just a option. This is just option. This is
Okay,
option
okay.
one.
Mm-hmm.
This is option two.
Okay, sir, got
So
it.
after
So,
this,
sir, got it, sir. You just I can ignore it, sir. So after that, we got this x value, y value, and z value in terms of those vectors. Till
yes.
that point, I am okay, sir. After that, we have substituted a as y. Okay,
Hmm.
okay, okay. Got it, sir. Got it, sir. Got it.
And
My mistake.
if you
Yes, sir.
put the value of a into this equation,
Yes,
we
sir.
get the
Yes, sir.
value
Yes,
of b also.
yes,
And we just
yes.
write z, from this we get z equal to x
X
minus y.
minus y. Yes, sir. Yes, sir. Solving this equation. Got it, sir. Got it.
So this question is clear. The range of F form a plane in R3.
Yes, sir.
Yes, sir, please go ahead, sir.
So here the question is saying the transformation T is bijective injective. So here the nullity is 0, right?
Yes, yes.
For checking 1 1, what are the conditions for checking 1 1?
So T of 0 equal to 0, we can check that also.
If nullity is equal to 0, means the nullity of a given linear map is 1 1 if nullity is equal to 0, right?
Yes, it is already satisfying, no, sir? X equal to 0 for X equal to
It's
A.
surjective, no?
So here we find nullity is equal to 0, means this linear map is 1 1, right?
Yes.
Hello.
Yes. Yes,
And
sir.
for checking onto, what are the conditions for checking onto?
Oh, sir, can you please write down the properties also? For 1 1, it is nullity has to be 0.
Nullity and onto dimension of codomain is equal to rank of T. For this, dimension of codomain is equal to rank of T
Okay, sir.
for onto, for checking onto. So here, so what is the dimension of codomain here? Codomain is here what?
Codomain is dimension of
Three.
This,
codomain is 3, right?
Three.
yes,
R2.
yes. And rank of T is what?
Two, sir.
2.
Is
2, 2,
both are
sir.
equal?
No,
Is
no,
both are
no.
equal?
No, sir.
No.
So this is
Not,
not onto, right?
not surjective.
So injective but not surjective.
Yes, I got it.
So here we have, we have the projection is defined like this: from projection operator from R3 to R3 with the projection with a standard inner product on R3. So here we are using a standard inner product, means dot product on subspace W. Means W is subspace W is defined like this. Basically, this is a plane, and we have to find the projection of this vector 1 comma minus 2 comma 0 onto the subspace W. So how we find the projection of this vector onto W?
We have to find the basis for W.
So for finding projection onto this subspace W, first we need to find the basis for this W. Then we convert this basis into orthonormal basis. Then we have to find the projection. So how to calculate the basis for this W?
You can take
We take
any
y is
Z.
equal to 3z minus 2x.
So here we have equation, right? 2x plus y minus 3z. So just writing, I'm writing the step for finding projection. Find basis. And the second is convert normal basis. Then use this formula. This is n to I to n, to so b into bi. So here vi are orthonormal basis for this subspace W. Got this formula? This is the formula for finding the projection onto subspace. So how we find the basis for the subspace? Can I write y is equal to 3z minus 2x from
Yes,
this,
yes.
Yes.
and here, so here x, and the value of y is what? 3z minus 2x,
Minus 2.
and z is here. So can I write like this? X minus 2x
Minus 0,
plus
0, comma
and
3, 3,
0 comma 3z
comma 0.
z. So can I take x outside?
Yes, sir. 1 minus 2,
Means this is the basis for this w, right? Hello.
yes, sir.
Yes, 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 yes.
Is
Yes,
2
sir.
So what are the dimensions of for this?
2, sir. 2, sir.
Okay.
So check if these two vectors are orthogonal or not.
Zero minus.
It is
No,
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 sir.
sir.
No.
No,
no.
no.
So we have to convert this two
Gram
vector
speed.
in, yeah, to orthonormal vector. So for converting orthonormal vector, we have to use Gram-Smith process,
Mm.
right? So the first step is
You, yes, sir. V1 and V2.
just take this vector, first vector, and divide by it norm. So what is the norm of this vector?
1 by root 5. Sorry, root 5 is the no.
1 by root 5 times 1, comma minus 2, comma 0.
So norm of this vector is root 5. I just got this how I could. So norm of
Yes,
this
sir.
vector is what?
Square root of 1 square plus 2 square.
And just I am taking this as a just take this the v1 down v1. So how to find v2? Suppose this vector is x2. I
Zero
am
three one.
just
Subtract 031 minus
0 3
mm,
1
minus
minus in a
the dot
Project
dot
V1.
mm,
projection of this vector onto this
Again,
subspace.
yes,
on V1.
031
Yes.
Yes.
1 minus 20.
I just take 1 by root 5 common here. Here is
So we
root.
can anyways do 1 minus 20, and anyways in the bottom we will have to multiply. So we can, okay,
So
we can do
don't
this
we have to normalize the second vector to 0, 3, 1?
Here
after,
no.
after this. I think we'll have to normalize, right?
After this we have to normalize.
Okay, the entire x2.
Yes. Yeah.
Can I take this vector? This is just a scalar, right? Using the properties of inner
Yes, sir.
product,
Scalar
I
can be
can
taken out. Yes.
if I take this outside, if I take outside, this will become what? This is also scalar, right?
Yes.
So this will become 5. What this one? Hello. This is also some scalar, right? We can write here, also we can write also here. So root 5 into root 5, we get 5. Hello.
Okay. Yes. Yes.
Yes. Yes.
Now compute this dot product.
Minus 6.
So minus 6.
Here there is a mistake.
So this dot product is minus 6. So means plus 6 by 5. And what will be this value?
6 by 5, comma,
This one, 3
3
minus.
by 15,
So this will be
1 by
3
5.
minus, no,
So
15
it will
minus.
be, yeah, 3 minus 12 by 5. So that is 1 by 5.
12 by 5.
That is
So this is
1
what,
by 5.
15 by, this is 3 by 5, bro. Right? So
Yes,
this
sir.
is what, 3 by 5. And the third one, 1.
Sure.
This is 1, right?
Okay.
Just I'm
Yes.
just adding.
Yes, sir.
For simplification, can I write this thing as a 5 by 5?
Yes, sir.
Now we have to normalize this vector x2.
Sir, 6 by 5, I just lost it where? 6 by 5, yeah. Zero one
This one.
three one. Can you help with this? Yeah, lost it part.
So here, okay, I will 1 by root square root of 5. So this is the formula for Green process, right? Green Smith process. This one. So I just take out this constant. So what will be dot product? Just find dot product here. So what will be 6 by root 5, right? Hello.
1 upon root 5 is taken outside, and 1 that will become 5. 1 upon 5.
Yes. So we can take this outside, right? I just take outside. So this will become this, and this is some also. This is also a scalar, and this is also a scalar, right? Hello. And
Yes,
if you
yes.
multiply these two things, what we get? 1 by 5, right?
1 by 5. Yes.
And the inner product between these two vector is minus 6. So this will
Okay,
become,
okay. Got that.
got this?
Yes.
And if the dot product is between this is minus 6 and this is minus, so this will become plus 6
Minus,
by
minus,
5.
plus. Okay.
Now we have to normalize this vector.
5 by 5.
So calculate the norm of this vector. So what will be the norm?
Root over 70 by 5.
So, so this will be root over
70.
70 by
Root 70
this
by 5.
20, 25,
25.
right?
Root 25. Square root.
And this value is what?
Root 70 by 5.
Means this is, we can write like this, 14 by this is 5. Can I write like this here? No.
It's best to, because
Yes.
we be able to cancel 5 and 5 also, no? So 6, 3, 6, 3, 5 by root 70 will get.
Yes, we can also write like this here.
Sure, sure, we can do that. No problem.
So it will be easier. This will be 14. This is root 5. Now we have to divide this vector is by norm, right? We have to divide this by this. What we get? So W2 will be what? D2 will be what? If you divide this vector by this, what we get?
6, 3, 5 by root 70.
So 6 by
6 by root 70.
root 17. And the second one,
3 by root 17. 5 by root 7.
so this will be 3 by root 70, and this will be what? 5 by.
5 by root, 5 by root 7.
Now just check the norm of this vector. So this will be 1, right? If you check
1,
the
1.
norm of this vector.
Yes, yes. 1.
Now check, now confirm these two vector are
Sir,
so
sir.
hmm?
When we have just created the norm,
Hmm?
then 635 divided V2 calculation is
So we just take this vector and divide by this. If you divide this vector by this quantity, we get this. So we can write like here. So this
Yes, sir.
is,
We are getting 0, sir. U1 dot U4.
I'm just explaining this step. So this is what?
Multiplied by root 5 by root 14.
So this is times, and this is, can I, here root 5 will be there, right?
Yes.
And this
square
Divide.
root of
quantity,
5
this
into square root of 14.
no. So I'm just explaining why we get this 6 by under root of 70. So
Yes, sir.
can I write root 5 time root this 5 into root 5 into 5,
Okay, 70. Got it.
and we can cancel this root 5 above and numerator into denominator, this one, and this is what we can also take this 5 inside this will become 70. Got this?
Yes, sir. Yes, sir.
Now check these two vector are orthonormal or not. So just find a dot product. If dot product between these two vector are 0,
Yes, yes.
means this both vector are orthonormal, right?
Yes.
Now you have to, we just calculate this step, second step, convert the basis into orthonormal basis. Now we have to use this formula for finding the projection. So what are the b here? So we have to find the projection of this vector 1 comma minus 2 comma 0, right? We have to find the projection of this vector onto subspace W. So what will be this? This b is what? This b is, so what is the value of n here? How many basis vector we have?
2.
2.
2. So we just remove this. Just put here 1 minus 2 0. And what is v1? V1 is what, this one?
Plus this.
This is v1. Then plus inner product and this, the second vector. This, you got this? This is the formula, right? You just apply formula here. Any doubt here?
No.
Hello. Now just solve this. So the dot product between these two vector will be what? Inner product between these two vector. This will
5 by
be
root 5.
5 by root 5. So can I write like this here? 5 by root 5, and root 5 into root 5 is what?
5.
5.
5. And we can cancel this 2, right?
Yes, sir.
So we get 1 comma minus 2 comma 0
Yes, sir.
plus, now find the dot product between these two vector.
0,
What is
0, 0.
0? If it is 0,
Then
this
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 entire will be 0.
yes, I get 0 vector. And what we get? 1 comma minus 2 comma 0. So projection of this vector, so
It's a,
the projection of this vector onto subspace W is what? This thing, right?
so it's the vector itself.
Vector is.
Yes. And if you observe this,
This is a.
so
This is one of the basis vectors only.
yes,
It lies
means
on the subspace.
Yes.
yes. So
Right.
from where is question here? So means this 1 comma minus 2 comma 0 is vector lying on this plane, right? This look, this
Okay.
vector is lying on this plane,
Yes,
and
sir.
we know the property, right? If suppose if V belongs to W, then projection of the projection of this W D will be what? If V belongs to W, then projection of D will be what? B, right?
Yes, sir.
Is basically this vector already lying on this subspace, and then again we are projecting. This is so this will not change, right? Suppose the vector already lying on the subspace W, then again we are projecting the vector onto this W.
Yes.
So if we know this property, we can directly say this the same projection. We don't have to solve this all the thing. We observe this, we can directly say
Yes, sir.
what this. Now the question is asking find the value of A plus B plus C.
Sir, can you please explain the last part, projection and getting from equation? Yes.
So this one.
Yes, yes.
So here, if V belongs to W, means B already lying on the W subspace W. Then the projection of B onto W will itself be basically suppose you have this this is a I think we have to use pen. Just imagine
Yes, sir.
so
In
just imagine this is a just a so just imagine this is in R3, right? This vector lie on R3.
yes.
Suppose this is three dimensions dimensional subspace. Suppose this is how is okay. I have to use
So
this one.
let's move on.
So
So
just remember this.
basically, on the subspace, if a vector lies in a subspace, then it will satisfy the equation of the subspace. We are just
Yes,
substituting it in the subspace equation, the vector, and if it
yes,
satisfy, we can see that the vector itself uh, uh,
yes,
is the projection of itself
yes.
on
So
the plane.
yes. So if you want to check this vector lie on this plane or not, just put this vector onto this equation. If this
Okay.
satisfying this equation, then this vector is lying on this plane. So if you put one,
Okay, that
so this
means
will
no
become
need to do all this step, or is it
yes,
required?
yes, yes, yes. Just remember this property. If V already lie on the W, then projection of V onto W will be V again.
So basically, in this case, we will simply put this 1 minus 2 0, this vector, onto the equation of the plane. Sorry, yeah, this plane. And then if it satisfies, then we can simply use this property.
Yes, yes,
Otherwise, we have to. do the
Yeah,
entire
otherwise we'll
step.
have to do the entire
And
step.
ABC, sir.
Yes. Hello.
ABC.
So ABC is the value of this projection, right? Projection of this
The
vector
final
onto
result we
subspace.
have calculated.
So the final result is -1. So just add this to this value. So if you add this, what we get? -1, right?
Yes, sir.
This is -1. For this,
Yes, sir.
so here, if alpha, beta, gamma is a vector in kernel of PW, this projection of W, then find the value of alpha plus beta plus gamma. So here alpha, comma, beta, gamma belongs to the kernel of this projection. So what is the definition of kernel of
null
projection?
space.
Yeah. So kernel of PW is
It will be W per, right? Basically.
Yes, W per.
yes W for yes for also kernel. So means W per is what? Perpendicular is what? Set of all vector x comma y, x comma y comma z, such that, so if I take u, I am just taking u is equal to x y z, such that the dot product between u and
XYZ.
the no, this u is x y z, right?
Okay, okay, okay.
Okay. So dot product between u and basis of w
Will
will be
be
0,
zero.
right?
Zero.
Yes, yes. Orthogonal.
Suppose the basis,
Orthogonal.
suppose we here we find basis what? Just so just use this basis, this one basis.
1 minus 2 0.
So yes, don't, we can also use this. We can also use, but this will be simpler.
Yeah, yeah.
Yes,
So
sir.
otherwise use this.
Will be complicated.
Yes. So just find a, so this is v1 is equal to 0 and u dot
V2 is 0.
v2 is 0.
Sir, in the earlier situation where the vectors got normalized,
Hmm?
that is
Hmm?
like W part is just a subspace of it, na?
Here,
Like W is a subspace of that.
yes.
So we just
So
don't need
this,
to do the projections.
so you were telling that this vector already lie on this plane. Hello?
Yeah, but what is like we don't need to do the projection when like the whole scenarios are not connected.
So, so here
When
we
vector space is equal to okay, understood.
got it.
Yes, agreed. So the alpha beta, please can yeah.
This one. So this, if alpha, beta, gamma is a vector in the kernel of this projection of W, so this is the kernel. We can also say W perpendicular kernel of PW, and this is defined like this. So this is a set of all vector such that the dot product between u and v1 will be 0 and u into v2 will be 0. Let's take this x. Let's take x1 next. So here x1 and x2 are the basis for this W, and we find this one. So just find a dot product between this vector times this vector and this vector times this vector and equate to 0. So what will be the dot product between these two vectors? This vector
X
times this
minus
vector.
2y equal to 0 and 3y plus z equal to 0
So this will be x plus minus 2y
equal to 0
0, and
and
this thing, and this will be what?
3y plus z equal to 0.
Z equal to 0. Now solve this both equation.
X equal to 2y and y equal to z equal to minus 3y.
So what we are getting?
X
X
Zero.
x equal x equal to 2, and so just use here, just make matrix. It will be easier. So make the coefficient matrix. So what are the coefficient of x is here? So this will be, so this is what coefficient of x is 1, coefficient of y is minus 2, and z is 0, and this is 0. Got this one?
Yes,
How we
sir.
get this? Now solve. So we are basically solving. So what is the value of x? So can, for solving this, we have to make this in RRF, right?
Yes, sir.
So just divide this second row by 3. We get 1 by 3. And we want to make this element also 0. So what we do? Just if you do R1 plus 2R2, this will make 0, right? This can be 0. And this will be 2 by 3. So the value of, so here tell me which variable is independent here.
Z.
z.
So z is independent. So can I take z is equal to t?
Yes, sir.
So if z equal to t, then the value of x will be what? Minus 2 by,
Minus 2 by 3t.
3t. 2t by 3. Yes.
and the value of y will be
Minus 1 by
Minus
3.
t.
minus t
1
by,
by 3 by 3.
and then the solution of this system will be x y z. So minus 2t by 3 minus t by 3, and this is t. And this is what? This vector is what? This is projection, right? This is, means this is
Can we
the
calculate the
vector.
projections in this similarly?
So this is not a projection. This is basically the vector in the kernel, right?
Yes,
Hello.
yes.
Yes, sir.
Yes, yes.
Hello. Now the
Yes, sir.
question is asking.
Yes,
Now
yes.
the question is asking. Find the value of alpha plus beta plus gamma. So just add these three. Hello.
Yes, yes, got it.
Yes, sir.
If you add these three, what we get? 0, right?
Yes.
Yes, 0.
Sir, we can do one more thing, right? Can you just go over? Sir,
Yes.
rather than going and solving this one, because we are already getting x equal to 2y and z
Hmm.
equal to minus 3y. So the kernel vector that we are getting basically in terms of y, we are getting is minus 2y, comma, y, comma 3y.
Hmm.
So if we add that also, then also we'll get 0 only. Minus
Yes.
2y.
Yes. Yes.
Yeah,
Yes.
2y,
Yes.
comma, y, comma, minus 3y. Yeah, you can add do
Hmm.
that also. Same only.
Yes. Yes. We can also do. And what is the dimension of orthogonal complement of W perpendicular?
One, right?
So 1. So remember this. This W perpendicular, dimension of W perpendicular plus dimension of W W is equal to what? B. And B is what here? B is domain. So here project domain of this projection is what?
3.
3. And here what we get the dimension of this W perpendicular?
1.
1. And here
It
we
was,
can also find dimension of W is what?
so it
2,
was
right?
given 2.
So we can also find here we can also find dimension of W perpendicular from this information
Okay.
also, this 2. And remember this also, W perpendicular so W perpendicular is W is equal to 0. So you got this problem.
Yes, sir.
So here consider the graph of this. Hello.
So how many more questions are there? Just wanted to ask.
I think only 2. I think. Can I do this question tomorrow? I think tomorrow is also session. Can we do this?
Yeah, no issues, sir. So
Sir, all
just please
sessions are
upload
there.
this.
Sir, any like session for instructor also?
I think all